Hello, Pre-Algebra Mr. Lawrence here with your flipped lesson, and today we are talking about the Ka part of SOHCAHTOA. I'm going to put some triangles up here, some right triangles, and I'll do a couple different types. And, oh, it doesn't want to draw, does it? Alright, let me turn it. Ooh, look like that. Okay, and I'll make it a little bit bigger. And then this one here, let's go like that. Okay, so let me put my right angles in here so that you know where they are. And there we go. All right, and we're going to learn about the Ka part today. But before we do that, the first thing I'm going to do is I'm going to play a little game with you. I'm going to put a theta in a place. Okay. And I'm going to put some stars for the measures of sides. I'm going to put one by the hypotenuse, and I'm going to put one here. I'm going to put one by the hypotenuse in there, and I'm going to put one by the hypotenuse in there. Now pretend those stars were numbers, and those smiley faces were thetas, or degrees. You know, like 25 degrees or 45 degrees. Could you use the SO part of SOHCAHTOA to figure one of these things out? Well, let's see. The SO part of SOHCAHTOA says use the sine of theta, right? How big the angle is. And you do the opposite side over the hypotenuse, right? Okay, so I'm going to look and see if I have the hypotenuse in the triangles that I gave you. And if I know the side opposite the smiley face or the theta. Well, let's see here. I'll tell you, I'll do it this way. I'll do the hypotenuse in yellow. Yep, I know the hypotenuse. Do I know the side opposite? Well, let me go. Boom, it's opposite. There we go. That could be a SO problem if I knew the values of the stars and the smiley face. All right. The second one, I know the hypotenuse. I'm going to go opposite. Yep, I hit a star. That's a sine problem. Okay. Well, on the last one, there's my hypotenuse. And I'll go opposite. And sure enough, I hit a star. So all of these could be sine problems, or the SO part of SOHCAHTOA. All right. But what happens when I know something different? I'm surprised those symbols disappeared, but that's okay. Well, let me see here. Let me move this down a little bit. Something like that. There we go. And let me put in these. I'll put the smiley faces in. And I'll put my stars in. Now, if you check these, I know a hypotenuse, but I do not know the side opposite. No, I don't. Now, you could, if you knew the degree of the smiley face, you could subtract it from 90 and then get the other side. But in this case, we don't know the opposite side. So we're going to say right now, you can't use the sine on this. Not as it is, not without doing something to it. All right, so the second triangle, the middle one, well, there's my hypotenuse. And the side opposite, do I know it? No, I do not. So we can't use the sine on that. Last triangle, there's my hypotenuse. The side opposite, I don't know. No information about it. So I can't use sine on any of these. Okay, well, in this case, I am going to use something called the cosine. Or I'm going to use the Ka part of SOHCAHTOA. And the Ka stands for the cosine of theta. That's going to equal a fraction. H is still the hypotenuse. Now, the A is an A word that means next to, and that is adjacent. All right. So the cosine of theta is the adjacent over the hypotenuse. In other words, you're going to do these almost the same exact way as you were doing the sine problems. But you're going to use the cosine function, and it's going to involve the adjacent side and the hypotenuse. Now some of you are going to go, wait, Mr. Lawrence, I see this smiley face here, this theta. It's got two sides next to it. No, because this side here is the hypotenuse, right? So the adjacent side is this. This is the adjacent one. It's the side next to it that is not the hypotenuse. All right. This smiley face here, that's the hypotenuse, so that's the adjacent side. It's next to it. This smiley face here, there's the hypotenuse. The adjacent side is that one. So these are all CAH problems. So let's see how to do a problem of this nature. Let's have a right triangle. Okay, and I'm going to tell you that this is maybe 20 degrees, and I'm going to tell you that this is x, and that is going to be 30 meters. You do these the same exact way. You stop and look and say, well, I know the hypotenuse, and I know I'm looking for the adjacent side, not the opposite side. So I write down the cosine of 20 degrees, you always do the cosine or the sine of an angle, equals the fraction of x over 30. Put that over 1, and I'll cross multiply. 1 times x is x. 30 times the cosine of 20 degrees. And at this point, I can go to my calculator. You know, you want to make sure that you're always in degree mode. And so it's 30, the cosine of 20. And there you go. It's about 28 and 20 hundredths. Oh, excuse me, 19 hundredths or 28 and 2/10. So x would equal 28.19, 19 hundredths. All right, it's that simple. It really is. If I have a right triangle like this, where I'm looking for the hypotenuse, and I know maybe this is 40 degrees, and I know this is, I don't know, 12 centimeters, right? Oh, did I forget the label on this one? Yeah, that should be, what was it? It was meters. Sorry. Okay. Well, I'm looking for the hypotenuse. I know the adjacent side to the angle, right? Didn't go all the way across, went next to. So I'm going to use the cosine of 40 degrees, and that's going to equal the adjacent side over the hypotenuse. Put that over 1. Oh, Mr. Lawrence, the adjacent side is 12. Silly Mr. Lawrence. The hypotenuse is x. Remember, the hypotenuse always goes downstairs in the denominator. So I'm going to get 12, and that's going to be equal to x times the cosine 40 degrees. And then I'll divide each side by the cosine of 40 degrees. All right, x will equal 12 divided by the cosine of 40 degrees. I only said that like 85 times. 12 divided by the cosine of 40 degrees. And I'll get approximately 15 and 66 hundredths. So x will equal 15 and 66 hundredths centimeters. Pretty simple stuff. Now, you can also use the inverse cosine. If I have a right triangle and I don't know the measurement of theta, and I know that this is, say, 25 centimeters, and I know that's 24 centimeters. Well, oops, that wouldn't be a cosine problem, would it? Who can tell me why that wouldn't be a cosine problem? Yeah, the 24 is in the wrong place. That would be a sine problem because I know the opposite. So I'll put the 24 over there. There's my hypotenuse. That side is next to it. It is not adjacent. This is a cosine problem. I'm going to do the cosine. The cosine of what? Of the degrees, but I don't know the degrees. It's the cosine of theta. All right, and that'll be 24 over 25. And I'll put it over 1. Nope, unnecessary. I won't put it over 1. Remember, when I'm looking for theta, I know that theta is going to be equal to the inverse cosine of 24 over 25. And at this point, I can go to my calculator. So I'm going to do the inverse cosine, second cosine, like that. 24 divided by 25. And I'm going to get an angle of 16.26 degrees, or 16 and 2600ths. So theta is going to equal 16 and 2600ths degrees. And there you go. All right, Mr. Lawrence signing off. We'll get some practice with this in class tomorrow. Good night, everybody.